Hey folks, today we're going to talk about predicting double replacement reactions. Let's get right into it with the first one. Let me go through these and then remind you what your rules are as we do it. Right, remember what we have to do is we have to look at what our metal is and what our metal is, and we're going to say they replace each other, or we think they're going to replace each other. So what we do is we come up with barium sulfate, and we come up with sodium nitrate. That's our first step. Then what we have to do is we have to say, does this really happen? Before we're even going to get into anything else, does this really happen? So we have to look for each of these four things on our solubility table. So the first is sodium sulfate. All right, we have to make sure, remember, that your first two, your reactants, always have to be, your reactants must be both aqueous, and your products can only have one aqueous, and the other has to be solid or liquid or gas on the right. So you have to make sure that your reactants both are aqueous, and they both have to be aqueous or the reaction doesn't happen. So we're already told that sodium sulfate and barium nitrate are aqueous, so we don't have to even look them up. But we do have to look up barium sulfate and sodium nitrate. So let's look at, for first, barium sulfate. All right, so what we do is we come over here and we look at barium, and we come over and we find sulfate, and we look to see what it says. And it says that that's a solid, that barium sulfate is going to be a solid. So this is going to be a solid. And sodium nitrate, let's go back and look at sodium nitrate. Well, we have sodium way down here. We look for nitrate, and there's nitrate. We look to see where they cross, and we have something that is aqueous. So, we have, in fact, figured out our rules. Our rules are, in fact, correct. Now, we do have to balance this equation. You'll notice we have two sodiums on the left. We only have one on the right, so we have to put a 2 coefficient in front of that, which gives us two nitrates, but that's okay because we do have two nitrates over here. We only have one barium and one sulfate, and we'll notice that on the right we have one barium and one sulfate, so that all works fine. So we do have a balanced chemical reaction now, and it does in fact happen. So in fact we are done with this particular example. Now, before I get too much further, let me notice something, just writing on this particular solubility table that we have here, just so that you notice something. Notice everything with sodium. Everything with sodium is aqueous. Wow, isn't that cool to notice? So if it's got sodium in it, it's aqueous. And I'm going to use that throughout this podcast because I'm too lazy to look this up every single time. Potassium, also you'll notice everything with potassium is aqueous. All right? So that's kind of good to know. You know, so if I see something with potassium and sodium, I know it's always going to be aqueous. Right? And also if I happen to look at nitrate down there, those are all aqueous. So everything for nitrate, those are all aqueous. Right? Now, of course, the other ones I'm going to have to look up, but I can tell that all of those are going to be aqueous. So that really helps me out. Okay. When I look at everything else, let's see, we do have acetate. If I look down acetate, everything with acetate is always aqueous. Right? So that really helps me when I'm going and looking at my different possibilities of what is and what isn't aqueous or solids or whatever. Some I can immediately rule out. So just kind of be aware of that as we're going through this. All right, so we now have sodium nitrate, and we have ammonium chloride, and that should go and make ammonium nitrate plus sodium chloride. All right. Well, remember we noticed that anything with sodium rather, is aqueous, and in fact we noticed, I'm going to go back to this one again, that everything with nitrate is also aqueous. So everything with nitrate is aqueous. Oh, look, we've got aqueous, 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 aqueous. So there's no driving force behind this reaction. So this reaction does not happen. So there's no reaction here. Right? So be aware of that. All right. So let's try this one. We've got lead nitrate and we've got sodium chromate. So we're going to switch these. So we get sodium nitrate plus lead. And what lead is this? What do we do there? Well, we notice that lead, we know that nitrate is a -1, and because we have a 2 down here outside these parentheses, that tells us this is lead should be a 2+ charge. Does it make sense that nitrate takes on a -1? Yes, it does. So this is lead with a 2+ charge. And chromate over here has a 2- charge. So this is 2 plus 2 minus are going to cancel each other out. So that's cool. That's easy. Now, we do have 2 nitrates. So we have to have 2 in front of here, which is good because we have 2 sodiums. So that all works out. So now we have a balanced chemical reaction. Well, the first two we're told are aqueous. We know that anything with sodium and anything with nitrate in it is also aqueous. So maybe lead chromate is going to be a solid. So let's look up lead chromate. So I found lead, and I found chromate. I want to get down to where they cross each other. It's a solid. So this one, in fact, is lead chromate is a solid. So this, in fact, is going to work. So we now have a balanced chemical reaction that actually works. All right. Let's look at number 4. The zinc and the potassium are going to switch. So I get KCl plus ZnCO3. And carbonate is -2, zinc is +2, chlorine's -1, zinc is +1. So they all cancel each other, but I notice that I have 2 potassiums on the left, I have to have 2 on the right. Also 2 chlorines, so that works out. All right, let's see what we have here. We have potassium chloride and zinc carbonate. Potassium, or remember, anything with potassium is always aqueous, so I don't need to think about that one. So we do need to go to zinc carbonate. So there's zinc. And carbonate, carbonate, carbonate. There you are. There's zinc carbonate. So I come down there, and I'll notice that I do have a solid. So the zinc carbonate is going to be a solid. In fact, I do have something that balances. I do have something that actually happens. So there's number 4. How about number 5? Number 5 is ammonium chloride and silver nitrate. Ooh, now we got to write them. Oh, words. Oh, yeah. Okay, ammonium, NH4, chloride, Cl, plus silver, Ag, nitrate, NO3. And that's going to produce, well, let's see, my 2 cations replace each other. So I get AgCl plus NH4, NO3. All right, well, that's step 1. And before I go too much further, let me see if this is even bothered to do. Silver nitrate is aqueous. How do I know that? Well, because nitrate's always aqueous. So nitrate is aqueous on both sides. And so we have to look up silver chloride and ammonium chloride. So let's look up, well, that's only the chloride we have to worry about. So there's chloride. And we have to look up ammonium, which is there. So ammonium is aqueous, and silver is solid. Ooh, the silver one is solid. Okay, so my silver one is going to be a solid, and my ammonium one is going to be aqueous. So the 2 things on my left are aqueous. The one on the right is solid, so that works. And let's see, I have a +1, -1. They cancel. +1, -1, so they cancel. So I don't have to worry about the rest. So everything cancels, everything balances. We are done, and that works. All right, how about number 6? Number 6 is barium acetate and copper chromate. If I remember correctly, barium acetate is aqueous, right? Anything that's acetate, barium acetate is aqueous. Cool. However, copper chromate, if I look at copper 2 and I look at chromate, if I can find copper 2 chromate, copper 2 and chromate is right there. Copper 2 chromate is a solid. Ooh, that's not good. So this thing over here is going to be a solid. A reactant is a solid. Can't happen. This reaction does not happen. So I can stop right there. Okay, how about number 7? Number 7, it tells me I have a solution of silver nitrate and ammonium chloride. Well, that implies that they're both aqueous. So I should have silver nitrate, AgNO3, and ammonium chloride, NH4Cl. And I should be producing AgCl plus NH4. Sorry, that was NH4, NO3. I seem to remember that silver chloride, is a solid at in a double replacement reaction. Silver chloride is the fifth one across. It's right there. It is in fact a solid, so that's cool. So silver chloride is a solid, and we know that anything with nitrate in it is aqueous. Anything with nitrate in it is aqueous. So I have to look up ammonium chloride to make sure we're okay there. Sorry. And ammonium chloride is ammonium chloride, and that looks aqueous to me. So ammonium chloride is aqueous. So let's go and balance our equation. Silver is +1, nitrate's -1, ammonium is +1, chlorine's -1. So they cancel each other out, and we have a balanced chemical reaction. All right. How about number 8? Solutions of lead nitrate and sodium chloride. Lead 2 nitrate, PbNO3, but this is lead 2. Nitrate has a -1 charge, so it's PbNO3 plus sodium chloride +1 -1 is going to give me sodium nitrate, NO3, plus lead chloride. And lead is lead 2, so that means I have to have a 2 there after my chlorine. Ooh. All right, so what happens? Well, let's remember everything with nitrate is aqueous. Nitrate is aqueous. And sodium chloride, oh yeah, it's got to be aqueous. Salt dissolves in water, right? So let's just look. Sodium, oh, everything with sodium is always aqueous, so I don't even need to look it up. So we've got lead chloride. Let's look at lead 2 chloride. Well, let's see, there's lead 2, and we come over 6 to lead 2 chloride, and there's lead 2 chloride, and it's solid. So we do have something that's solid on the right. We have everything else that's aqueous. We have 2 nitrates, we have to put a 2 here. We have to put a 2 in front of the sodium. We then have 2 chlorines, so that all balances. We now have a balanced chemical reaction, and we are done. All right, how about number 9? We have zinc sulfate, ZnSO4, plus magnesium chloride, MgCl. That happens to be MgCl2 because magnesium has a 2+ charge, and chlorine has a 1- charge. So we have MgCl2. And zinc has +2, sulfate has -2. So now we're going to go and swap them. So we get zinc chloride plus magnesium sulfate. That was good, Skip. Magnesium sulfate, SO4. Magnesium sulfate. All right, so let's go look. We have zinc sulfate. Zinc. Zinc is the one that's all the way at the bottom. Zinc sulfate is the next to the bottom, next to the last one on the right. Zinc sulfate. And we have zinc chloride. So while we're in the zinc row, let's look up chloride. Zinc chloride, there's zinc chloride. Now what else do we have? We had magnesium chloride and magnesium sulfate. So we go up to magnesium. We look at magnesium, and guys, make sure you're looking at magnesium and not manganese. Right? It's important because they are different. And we notice that with magnesium we have aqueous, 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 aqueous. Ooh, that's yucky. Aqueous doesn't work. So nothing happens here. There is no reaction. Okay, we need something to be a solid or a gas or something else on the right. And because nothing is, we have no reaction. Right. Let's try number 10. We have ammonium phosphate. It tells us it's a solution, but it doesn't hurt to check. NH4PO4 plus zinc chlorate, Zn, ClO3. Now, what charges do we have here? Oh, let's get that later. Let's see if this happens first. Zinc phosphate plus ammonium chlorate. Guys, and if this is confusing to you, if coming up with the names is confusing, look at the words. We have ammonium phosphate and zinc chlorate. And what we're doing is taking the first two words and we're reversing them. That might help you if you're confused. So it becomes zinc phosphate and ammonium chlorate. All right, well, let's look at what we have. We have ammonium phosphate. And so we have ammonium, which is here. Phosphate, aqueous. Zinc, carbonate. Carbonate is there. Zinc is all the way at the bottom. Zinc, and we have a solid for zinc carbonate. So let's look at our other ones. We're going to have ammonium carbonate, which is aqueous, and we're going to have zinc. We're going to have zinc phosphate is a solid. All right, so zinc phosphate is a solid and zinc carbonate is a solid. Zinc phosphate, oh, I'm not looking at carbonate, I'm looking at chlorate. Excuse me, my bad. Chlorate, is that chlorate? That's chloride, that must be chlorate. So this one must be chlorate. It's hard for me to read it. Ammonium is aqueous, and this one is zinc is also aqueous. So these guys don't matter up here. We're not looking at that column. Okay, so the only thing that's going to be solid is the zinc phosphate. All right, so zinc phosphate is going to be solid, and everything else is aqueous, which is what we would have expected. All right, and now we have to balance. We have one ammonium on both sides. We got one, oh, wait a minute. We didn't do that right. Zinc chlorate. Zinc is a +2. Chlorate's a 1-, so we have to have 2 chlorates. And zinc is a +2, phosphate's a -3, so we have to have 3 zincs and 2 phosphates. And NH4ClO3 works just fine. And ammonium phosphate, I missed that one, folks. Ammonium is a +1 and phosphate's a -3. So now I have to balance. 3 ammoniums on the left. I have to have 3 ammoniums on the right. 3 chlorates on the right. We have to, oh, yuck, we have to have 6. But wait, no. We have 2 chlorates over here. We have 3 chlorates here. That's not going to work. So we have to have a total of 6. We're going to put a 3 in front of there, which means this is going to change to a 6, which means NH4s. We've got 6 NH4s, so we've got to have 2 of those. So we got 2 phosphates. That's correct. 3 zincs. That's correct. 6 chlorates. That's correct. 6 NH4s. That's correct. We are, in fact, balanced. Wow, that was messy. Okay. Number 11. All right. We have a solution of aluminum bromide. Aluminum bromide and iron 2, Fe, iron iodide. Now guys, remember I haven't balanced these yet, but I'm just trying to figure out if they even exist, so I don't waste my time going through a whole bunch of other steps that I can figure out. All right, aluminum bromide. Let's look for aluminum bromide. Aluminum bromide. Aluminum is here, bromine's here, so it's aqueous. And my other one is iron iodide. Which iron is it? Iron 2. So it's iron 2, and it's iodide. So we come down here. So we have iron 2, and we have iodide. So what do they become? Well, they become aluminum iodide, and they become iron 2 bromide. And they are all aqueous. So since they're all aqueous, no reaction happens. So we can skip number 11. All right, we have 3 more to do, 12, 13, and 14. If we look at number 12, solutions of sodium sulfide and iron 2 chlorate. So sodium sulfide is NaS plus iron 2 chlorate are mixed. So my metals should reverse, so I should get FeS plus NaClO3. All right, So let's look at our, again, if it helps you, just take the words and replace them. Okay. So we're going to look for sodium. Wait a minute. Remember, anything with sodium is aqueous. All right. So that means sodium sulfide's aqueous. And that means sodium chlorate's aqueous. So all I have to look for is iron. We're talking about iron 2. So iron 2 sulfide and iron 2 chlorate. So iron 2, so we're looking only at this line, and we're looking at chlorate, which I believe is here, and we're looking at sulfide. Sulfide. Sulfide is at the end, and it's a solid. So iron 2 sulfide. Iron 2 sulfide is my solid. Iron 2 chlorate is aqueous, so that all works. So now I have to balance my charges and make sure that works. Well, sodium is +1, sulfur is -2, so I need 2 sodiums. Fe is +2, chlorate's -1, so that means I need 2 of those. +2 -2 cancel, +1 -1 cancel. So now we have to go back and balance our equations. We need 2 sodiums and 2 chlorates, so we're now balanced. And that's it for number 12. How about number 13? Copper 2 bromide, CuBr, and +2 -1 gives me that. And potassium phosphate, KPO4. And remember, PO4 is a -3 charge, potassium is +1, so it's K3PO4. Sorry, my bad, that's supposed to be a plus. Gives you, now remember the metals reverse, so it's KBr plus CuPO4. Right, again, before I spend a lot of time looking at this, let's make sure that we actually have something to work. Copper bromide, so we have copper 2, and we have bromide, and so we have copper 2 bromide, which is here. And that works. It's aqueous. And we have potassium. Oh, remember, anything with potassium is aqueous, so I don't need to look that up. And we need to look up copper. We did that already. Copper phosphate. So we go to copper, and we go to phosphate, and we, whoops, there we go, it's a solid. Okay, so this reaction is going to happen because the copper phosphate is, in fact, a solid. Did I do that right? Copper phosphate. Yeah, that was 3 away. Okay. Sorry. Okay, so let's make sure that we have something that is balanced. We have 2 bromines. We have 3 potassiums. So as soon as we put a 2 in front of there, we're going to realize it's not right because we've got 3 potassiums. So the number that has to go in here, if 1 is 2 and 1 is 3, we go up to 6. All right, so now we have 6 Ks, 6 potassiums, which means we put a 2 there. And we have 6 bromines, which means we put a 3 there. So we put a 3 in front of the copper, and we definitely have a problem. Let's see, what did I do wrong? K3PO4, CBr2, it's copper 2. Oh, that's what I did wrong. Ooh, let's try this again. Let's get rid of everything and start all over. I made a mistake. My mistake is here. Copper 2 phosphate. Well, if it's copper 2, that means I need to have 3 coppers, and I need to have 2 phosphates. All right, so now let's try that again. I have 3 coppers. I need to have 3 coppers on the left. I've got 6 bromines now. That means I need 6 potassiums. It means I need 2 in front of there because I need 2 phosphates and 6 potassiums. So now I have something that is balanced. I like that much better. All right. Number 14. Here's the last one. Barium acetate. Barium is Ba. C2H3O2 plus zinc sulfate, ZnSO4, is going to give me, we're going to reverse the metals. So we have barium sulfate plus zinc, C2H3O2. Okay, so is this even possible? Well, let's look and see what we have. We have barium, barium acetate. Let's look at barium for a second. There's barium, there's acetate, and that's aqueous. Okay, and then we have zinc and sulfate. So we have zinc, which is the last one. And we have sulfate, which is here. And so we have zinc sulfate, which is aqueous. And that means we just check out the other corners of our squares. And we have a sulfate. We have a solid for barium sulfate. And everything else is going to be aqueous. So we have a solid for barium sulfate. So here's our solid. All right, now let's go back and balance charges. Barium is +2. Acetate's -1, so we have to cross them, so we need 2 acetates. And zinc is 2+, and sulfate is 2-, so they cancel each other out. And over here, barium and sulfate cancel each other out, and the zinc and the acetate do not, so we have to have 2 of those. But that gives us a balanced chemical reaction, where everything is aqueous, except barium sulfate. Okay, it's a solid, so that's our driving force. So that's the way we do them. So we are done. If you have questions, please see us in class, and we'll be happy to explain it to you. Okay? Have a great day. We'll see you later. Bye-bye.